Good day. For today's video presentation, I'll be talking about climate change. Okay, so before that, this is our intended learning outcome. You should be able to discuss climate change and its impact on economic, geopolitical, biological, and meteorological in the context of SDS. Okay, so looking at this picture, what you're seeing is a bear um, trapped into its habitat. Okay, and it's actually trapped because the ice caps are melting, and is this is also an example of habitat fragmentation, which is an impact of climate change. Okay, so we don't want this to happen into ourselves or to human race in particular. Okay, because we are also prone to habitat fragmentation. If ever sea level will continually rise um, at a very fast rate, well, sooner or later, cities, metropolitan areas will become Atlantis. Okay, but then again, I wouldn't want that to happen. So our goal is we should be able to discuss some concepts about climate change. So by that, we'll be able to um, to do practices which are environment friendly. Okay, so again, we begin with the definition of a term climate change. Okay, but let's dissect the term first. Okay, climate refers to general weather conditions of a place over many years. For example, the climate of the Philippines is tropical and maritime. It is characterized by relatively high temperature, high humidity, and abundant rainfall. Okay, so um, since it is a general weather conditions over of a place over a period of time, meaning to say, climate change is long term, and if we are going to compare it with weather, weather is just short term. Okay, so basically, um, when we talk about climate, so for example, June is a summer season, and so we expect next year that still June will be summer and in the years to come. Okay. On the other hand, when we talk about climate, weather. Again, it's a short term. It's a short-term weather variability, or it's a short term. I mean to say, if during morning it's sunny season, then in the afternoon, the weather condition will change. So it may be raining. Okay, so and that is the difference. Okay, so climate change then is a significant variation of average weather conditions over several decades or more. It is a long-term trend that differentiates climate change from natural weather variability. Okay, so climate change and global warming, as I said, are often interchangeably used. But we should take note that global warming is just one aspect of climate change. Okay, so how do we know that there is climate change, or how is climate change measured over time? Okay, so before, there were still no weather station projects, um, but but at present, we're able to project or to estimate what were the temperatures back then. Well, thanks to these paleoclimatology data, which are derived from natural resources such as tree rings, ice cores, corals, and ocean and lake sediments. If you recall, in one of my presentation, I told you that biodiversity, um, one function of biodiversity is for scientific services. So, meaning to say, we're able to study the origins of the world through through biodiversity. And again, these biodiversity are translated into these tree rings, ice cores, corals, and among others. Okay, so these proxy climate data extend the archive of weather and climate information hundreds to millions years back. Okay, so with these data, paleoclimatology data, again, we're able to estimate what was the temperature, or what are the temperatures at different regions of the Earth back then. Okay, but at present, we now have Earth orbiting satellites. We have remote meteorological stations and ocean buoys. So these are used to monitor present day weather and climate. So these are the present day instruments that we have to monitor our climate or our weather. Okay, so one is it's a weather station project, and we also have ocean buoys. Okay, so um, again, we contend that there is climate change. When you look at these global mean near surface temperature over 20th century over the 20th century from observation, and as obtained from 58 simulation produced by 14 different climate models, driven by both natural and human caused factors that influence climate. So we're interested here with the mean of all these runs, which is shown in red, in thick red line. So by then, we can see temperature anomalies from 1901 to 1950. Okay, so this is from 1901 to 1950. Okay, so basically, what is being projected or what is being reflected here is the global mean near surface temperature is actually increasing. Okay, so although we can see that there are some major volcanic eruptions, we know so well that if there are volcanic eruptions, or if there is a certain volcanic eruption, that would really alter, or what that would really modify our global temperature, because its particulates emitted by these volcanic eruption would accumulate into the atmosphere, and by that, if the sun if again it, if the sunlight will, should I say, enter into the earth atmosphere, instead of these heat being deflected or reflected back into the atmosphere, so they are trapped. It's because of the accumulation of these particulates, okay, and uh, coupled with greenhouse gases. Okay, so again, as we can see, if there is a volcanic eruption, we could really see that there is an increase in global mean surface temperature, but over time, it will the mean surface temperature will drop. But then again, when we look at from 1901 to 1950, it's a long span of time when major volcanic eruptions such as of Santa Maria and in Agong. So still, the mean surface temperature is increasing. Okay, so from 1960 to 2000, although there were three volcanic eruptions, but then again, the trend is increasing. So by that, we can see that there is climate change. Okay, again, one manifestations of climate change, or one aspect of climate change, is global warming. Okay, so let's take a look at these GIF. So what causes climate change then? Okay, so when the earth's okay so when the sunlight reaches the earth, okay, so some energy should have been reflected back into space. Okay, however, because of these greenhouse gases, um, these traps the heat from being deflected back into the outside the atmosphere. Rather, once it reaches the ozone layer, the heat goes back into the Earth's surface, and so by that, the temperature, or the mean surface temperature of the Earth is increasing, and it may be stored in the oceans, or if not, in terrestrial region. Okay, so with that, it causes global warming then. Okay, so well, we're interested as well if what are these natural causes, no? Natural causes of climate change. So as we all know, the Earth has gone through warm and cool phases in the past, and long before humans were around. So what are these forces that contributes to climate change? We have sun's intensity. It's really beyond our control. We have volcanic eruptions. Again, it's beyond our control. Changes in naturally occurring greenhouse gas concentrations. But records indicate that today's climatic warming, particularly the warming since the mid 20th century, is occurring much faster than ever before. Okay, so in other words, we already have the natural causes, and these are further triggered by 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 industrial revolution. And it is now a challenge. It's really a problem. It's because we cannot just uh, sacrifice our economy to preserve Mother Earth. But then again, um, we are enjoying right now, but we don't know what capacity or what is the maximum limit of which we can adapt with this kind of climate change. Okay, so um, okay, so what are specifically we also we also take a look into what are the anthropogenic causes of climate change, because diba, as mentioned a while ago, which is in this slide, that that global warming or that warming since the mid-century is occurring much faster than ever before. So um, it's because of these anthropogenic pressures. Okay, so basically we have greenhouse gases. So greenhouse gases occur naturally and are essential to the survival of humans and millions of other living things by keeping some of the sun's warmth from reflecting back into space and making Earth livable. But after more than a century and half of industrialization, deforestation, and large-scale agriculture, quantities of greenhouse gases in the atmosphere have risen to record levels not seen in 3 million years. So, as population, economies, and standards of living grow, so does the cumulative level of greenhouse gases emissions. So, this is what I'm telling you a while ago, that because of industrial revolution, so we are able to enjoy economic breakthroughs, luxurious lifestyle. But the downside, however, is that it is directly related with emissions of greenhouse gases. Because, for example, um, you're cooking using your liquefied petroleum gas or whatever you have in your houses. So of course, it's easier for you to cook. You don't need to work with the traditional way of cooking. It's too easy, but the cost of that is you are putting carbon footprints. So basically, each one of us is a contributor of greenhouse gases. Okay, so in particular, what are these greenhouse gases? Okay, so um, majority it's carbon dioxide, 76%. We have methane, 16%, nitrous oxide, 6%, and fluorinated gas, that is 2%. Okay, so these are some basic, well-established scientific links that, again, climate change is real. Okay, so the concentration of greenhouse gases in the Earth's atmosphere is directly linked to the average global temperature on the Earth. Okay, so meaning to say, if the concentration of greenhouse gases in the atmosphere is increasing, well, the global mean temperature is also high or increasing. Okay, the concentration has been rising steadily, and the mean global temperatures along with it since the time of industrial revolution, and the most abundant greenhouse gases, accounting for about two-thirds of greenhouse gases, is carbon dioxide. And it's largely the product of burning fossil fuels. Okay, it's so sad. It's because as much as we want to have a greener Earth, a greener community, but let's take this case. Our jeepneys are burning fuels in order to run the particular jeepney, and it's used for transportation. Okay, and also there's also politics. There's also politics in there that we cannot just easily get rid of these fossil fuels because we cannot deny the fact that these companies are paying a lot of taxes, and so if you're just to use such as other forms of transportation, which will no longer use these fuels, So it may be a challenge for the part of our government. So it's really difficult to weigh things out. But anyway, our task here is at least we can grasp some techniques or some practices which would somehow limit the emission of greenhouse gases in our own little ways. Okay, so there are some organization around the world which are responsible for curbing greenhouse gases emission into the atmosphere. Okay, so the Intergovernmental Panel on Climate Change was set up by the World Meteorological Organization and United Nations Environment to provide an objective source of scientific information. In 2013, the IPCC provided more clarity about the role of human activities in climate change when it released its fifth assessment report. So it is categorical in its conclusion that climate change is real and human activities are the main cause. Okay, so based on the fifth assessment report of the IPCC, so these are the major information they provided. That from 1880 to 2012, the average global temperature increased by 0.85%. Okay, and uh, we don't have data from 2013 onwards. Okay, so most likely it's increasing. Okay, so oceans have warmed. The amounts of snow and ice have diminished, and sea level has risen. Okay, so um, also the world's oceans will warm and ice melt will continue. Okay, warmer oceans means stronger typhoons. Melting of the ice caps, meaning habitat fragmentation for those animals and if there are plants living in the temperate regions. And again, that would also mean sea level rise. Okay, so this is an example of of increasing sea level rise. Uh, an example of an ocean of an island which is being wiped out by an ocean. I wasn't able to. I was actually searching uh, for for an article which shows a certain island here on Earth that is which is affected by sea level rise. However, let's just take this example. Okay, so it's an East Island before it's East Island. It's a Pacific Islander. It's a Pacific Island rather. Uh, which photographed before and shortly after Hurricane Walaka happened. So during May 4, so as you can see, the sandbar is still visible, but after the typhoon hit into this island, so only a small portion of the island is visible. Okay, so it's very fortunate that in the 3rd of May 2019, so um, the island begins to reform. Okay, so although this is not the product of sea level rise brought by climate change, but then again, we should picture out that this will likely be the scenario if ever, especially for those low-lying islands, if ever sea levels would continue to rise. So in this case, it's not fortunate, but it's good because it was just typhoon, and so the island just reform. But how about if it's sea level rise? So there is no way that the island will still be reformed or will still be visible after it is being engulfed with sea by ocean waters. Okay, so now we proceed. What are the major areas of concerns of climate change? So, um, before we discussed about the natural causes, the anthropogenic pressures, and also we discussed on the fifth assessment report of IPCC. Okay, now further, we're going to discuss what are the impacts of climate change, specifically in geopolitics, in economy, in meteorology, and in biology or in life forms. Okay, so we begin with the biological concerns. Okay, so there is vulnerability of biodiversity on the impacts of climate change. Okay, so I told in some of my video presentations, I told you that um, biodiversity is related to health, and biodiversity. I mean, climate change affects biodiversity, and so biodiversity affects human health. Okay, so in this case, that also may be classified as that can be classified rather as a biological concern of climate change, because basically all life forms here on Earth are very much vulnerable with the impact of climate change. Okay, so let's take this example again on habitat fragmentation. Okay, so um, habitat fragmentation would actually lead to low genetic variation. Okay, so supposedly I would like to give here an example of. I will just tell an example here. I will not use this illustration, but again, for you to visualize in what will be the result of climate change at habitat fragmentation, and with habitat fragmentation that leads to low genetic variation. Okay, let's take people here on Earth. Okay, so we have different nationalities. There are Americans, there are Filipinos, we have Japanese and our neighboring countries, and even European races. Okay, so if ever one of these days will happen that it will be very very extremely hot, so that all ice in the polar region will be melted, and by that some countries like European countries, countries in America, or countries which normally have cold weathers. So these people, because of extreme hotness, they will not be able to survive. It's because their body is not adapted to survive in hot temperature. Okay, so the tendency is that all of these races will die. It's because they do not fit into the environment. So, what will be left then are those who are fitted. So, most likely we Filipinos, those people in our neighboring countries, some African region, and among others, and some countries in South America. Okay, so there is no more genetic variation. It's because um, the people which are alive after the devastation, or um, uh, after that incident, are only adapted to warm temperature. Okay, but when time comes that what will hit us is a very very cold temperature. So most likely again, we're not adapted. We do not fit into a cold temperature, even if even if we are in the tropical region. But then again, an incident happened, which maybe there will be a snow. So because we're not adapted, so will die as well. In other words, there are no more persons who are adapted to very cold temperature because they already died ahead of us. The tendency is human races will be wiped out here on Earth. Okay, so that's the importance of genetic variation. Okay, because of genetic variation, organisms are preserved. They are still sustained, because if it happens that they have the same characteristics, and a certain incident uh, might come and they are not adapted into it, so basically they all will be wiped out. Okay, so climate change also has impact on wildlife. So global warming is likely to be the greatest cause of species extinction in this century. Okay, so the following are the species which are, should we say, very much vulnerable to climate change, and in fact they're already affected. So one is the tiger. Okay, so the tiger looks so fierce, but based on the numbers of tiger living in the wild, these numbers have declined to as few as 3,200, largely because to poaching and habitat loss. And climate change is likely to result in increasing sea levels and further risk of fire in the already fragmented habitats where tigers live. Okay, so if they will not be displaced because of sea level rise, well, they may be displaced because of wildfires. Or if they will not be displaced because of wildfires, they may be displaced because of rising of sea levels. Okay, so they do not have an escape. Okay, so we also have the Asian rhinos. Okay, so average temperature and January rainfalls are continue to rise. So causing changes to Asian rhinos habitat and their behavior. So these Javan rhinos rely on wallowing in the mud to regulate their body temperature. Okay, so if there is no rainy season and the drought is very very harsh, well, basically they don't have mud to wallow. So the tendency is that still they will die. Okay, so we also have the polar bears. Okay, so um, this is I think I don't have to expound more on this. So but well, one reason why they are very much at risk of the impact of climate change is because of habitat fragmentation. So if all ice in the polar regions will be melted, so basically they don't have habitats anymore. So we also have this one. These are beautiful birds. My apologies, not polar bears. Okay, so these beautiful birds can be seen in various locations around UKH summer. So they migrate here to breed, but as climate change causes changes to start at the end of the season, so migrating animals can find that they arrive at breeding grounds at the wrong time, meaning to say, uh, they are somewhat like deceived. They thought of coming into this particular region in UK that it's already summer season, and again, their purpose here is um, uh, to breed. And some are to actually find food. But then again, when they arrive, it's um, uh, still it's not the climate which is supposedly what they expect. So basically, they cannot breed because they are deceived. So, di ba, I told you a while ago that one manifestation of climate change is the changes in weather variability for changes in weather variability in a long-term pattern. So, meaning to say, supposedly June will be summer season, and so it might become a rainy season because of climate change. Okay, so um, another impact of climate change is marine and coastal the impact of climate change on marine and coastal biodiversity. So the reefs cover only 0.2% of the world's seafloor. They contain about 25% of marine species. So with increasing sea surface temperature and changes in water chemistry, it can cause large scale coral bleaching, so increasing the probability of coral death. And we don't want that to happen because without these coral reefs, well, basically, we don't have breeding grounds for our fishes. Okay, and that would, again, it has a domino effect on us, especially that we are consumers of these marine marine organisms, in particular fishes. Okay, so this is an Australia's this is a Great Barrier Reef on Australia. So it is expected that Australia's Great Barrier Reef could lose up to 95% of its coral living by 2050 due to changes in ocean temperature and ocean chemistry. So an increasing temperature would actually will lead to coral bleaching. Okay, and if there is coral bleaching, well, worst is that they may die. Okay, so uh, also another impact of climate change to life forms is in particular our human health. Okay, so climate change affects health through three pathways. One is directly through weather variables such as heat and storms. Okay, so it creates, for example, strong typhoons. So we know that during if there are typhoons, normally some people lost their lives. Okay, so that is direct. If it's indirect through natural systems such as disease vectors. Okay, so for example, I mean, one reason why a lot of scientists are very, very much uh, I mean, not just scientists, but even us are afraid of climate change, it is because these ice caps in the polar region are housing viruses, bacteria, which are dormant for a long period of time. So if these ice caps are melted, so basically these viruses will no longer be dormant. These bacteria will no longer be dormant. They will be activated and they will be integrated into our system, into the biosphere, and so these would potentially cause another diseases. Okay, and that is indirect. Okay, so through pathways heavily mediated by human system, such as undernutrition. Okay, so by 2030, conservative projections include worsening undernutrition, diseases like malaria and diarrhea, and heat mortality. So climate change is expected to exacerbate health problems that already pose major burden to vulnerable populations. So um, for us, no, just kanang sweldo. When we go, for example, we are from a room in a air conditioned, and when we go out, which is extremely heat. Um, when you go home, most likely we get cough, we get cold. So again, I mean, even thinking with the daily activities that we have, we're really affected by climate change. Okay, so we also have meteorological concerns. These are triggered again, impact of climate change to meteorological aspect. So one is heat waves. So these are periods of abnormally hot weather lasting days to weeks, and the number of heat waves has been rising in recent years. So I have here an example. So it's this is a case of Argentina. Okay, so time series of the number of heat waves, all lengths and stations over Argentina from 1961 to 2010. So the time series of the number of heat waves, as shown here, shows positive significant trend. So if you can see the trend is rising, so it means to say that the number of heat waves is increasing as time goes by. Again, from 1961 to 2010, and these are driven by these are driven by short heat waves. But then again, there are heat waves, and that is because of climate change. So we also have droughts. Okay, higher temperatures lead to increased rates of evaporation, including more loss of moisture through plant leaves. So even in areas where precipitation does not decrease, these increases in surface evaporation and loss of water from plants, which lead to more rapid drying of soils if the effects of higher temperature are not offset by other changes. Okay, so it could be heavy precipitation. So as I said, warmer oceans brings or creates stronger typhoons. So likewise, climate change could lead to heavy precipitation. It's because warmer air can contain more water vapor than the colder air. So global analysis showed that the amount of water vapor in the atmosphere has increased due to human-caused warming. So Mona, that's the reason why that if it's raining, I mean if there are typhoons if there are super typhoons developed because of warmer air, it creates a lot of rain, or it leads to heavy precipitation. Okay, so this is an example. Just last year, December 19. I mean, the news was published in December 19. It shows flooding, so because of the typhoon. Okay, so um, for the meteorological concerns, we have hurricanes. So, although scientists are uncertain whether climate change will lead to an increase in the number of hurricanes, warmer ocean temperatures, and higher sea levels are expected to intensify their impacts. So hurricanes are subject to various climate change-related influences. So, one is warmer sea surface temperature. These could intensify tropical storm wind speeds, potentially delivering more damage if they make landfall. And also, we also have sea level rise, so which is likely to make future coastal storms, including hurricanes, which is more damaging. Okay, so for economical concerns, countries in the tropics and southern hemisphere, subtropics, are projected to experience the largest impacts on economic growth due to climate change should global warming increase from 1.5 to 2 degrees Celsius. Vulnerable populations, some indigenous people, and local communities dependent on agricultural or coastal livelihood are at risk as well. However, if we limit 1.5 if we limit the warming at 1.5 degrees Celsius, so it is projected to result in smaller net reductions in yields of maize, rice, wheat, and potentially other cereal crops, and in carbon dioxide dependent nutritional quality of rice and wheat. Okay, so we also have geopolitical concerns. So, by the way, for economical concerns, no, I don't know if what's your position with this one. Back then, I had a student when I was still teaching in ESL school. Um, I had a student, I had a Japanese student who that during that during our classes rather, um, instead of learning the rules of grammar and so on, topics relating to English, so he would prefer that we're going to have a conversation about climate change because for him climate change climate change is somehow strategic for their country. It is because Japan is trading with European countries, and so these Japanese industries or these Japanese ships have to cross across the Pacific Ocean to the Indian Ocean just to reach Europe. However, if ever that the ice caps in the polar region will be melted, so it would be easier for them to transport their goods. They will just have to take another route that's heading north, and so they will eventually reach Europe uh, faster, and by that it could save them money. So, but for us here in living in the southern part of the world or southern part of the earth, well, we don't really subscribe into that idea because basically we're affected with sea level rise because what will happen to the melted ice, of course it turns into water and it will go down into the southern hemisphere. Okay, so now for the geopolitical concerns. So energy transitions are particularly associated with fundamental social change like industrialization, urbanization, and the emergence and growth of consumerism. So while such a transition may trigger a new era of energy geopolitics. So while for the last century, energy geopolitics has been synonymous with oil and gas, the growth of renewable energies and their economy is changing these conception. So our recent study identifies several mechanisms through which transition to renewable energy could affect global geopolitics, such as the development of new supply chains of critical materials and the cartelization of rare and precious materials used in renewable energy such as lithium, cobalt, and indium. A resource curse that exacerbates political and social instability uh, as petrostates lose access to high rents generated from fossil fuels, or a new resource in countries like in rare earth metals. Countries that dominate the export of rare earth minerals, effectively becoming the pre-petrostates of tomorrow. In other words, the business landscape will be changed because of this conception that we from fossil fuels we will resort to greener source of energy and increased cooperation or rivalry over sources of international finance and capital for investment and technology in energy sector. Then we also have increase in transboundary energy trade that could generate interconnections and increase interdependence among neighboring nations. It could also create geopolitical vulnerabilities for electricity importers and reduced greenhouse gas emissions that should logically reduce the risk of instability that climate change would otherwise generate. Then, unstable environments due to the effects of climate change on our transition pathways adapt that can influence investment in renewable energy by increasing the cost capital. Okay, so now we're going to discuss what are the steps which have been done in order to mitigate or to combat climate change. Okay, so one is the United Nations uh, Framework Convention on Climate Change. So in 1992, its Earth Summit produced the United Nations Framework Conventions on Climate Change as a first step in addressing the climate change problem. So today, it has a near universal membership. The 197 countries that have ratified the convention are parties to the convention. So the ultimate aim of the convention is to prevent dangerous human interference with the climate system. We also have the Kyoto Protocol. So by 1995, countries launched negotiations to strengthen the global response to climate change, and 2 years later adopted the Kyoto Protocol. So the Kyoto Protocol legally binds developed country parties to emissions reduction targets. The protocol's first commitment period started in 2008 and ended in 2012. The second commitment periods began on January 3rd, 2013 and will end in 2020. There are now 197 parties to the convention and 192 parties to the Kyoto Protocol. Okay, but what is sad in here is that countries, big countries, not just big countries but developed countries started to withdraw. Okay, so that puts us a question in mind: if these framework, if these treaties or agreements are still relevant even up to these days, if in fact again developed countries which are major consumer or producer rather of these greenhouse gases are withdrawing from the agreement, that way they cannot that way they will not be regulated as to the amount of greenhouse gases that they're going to produce. It's because if ever that if they will not be able to comply with the amount or with the guidelines set by this agreement, well, of course they have to pay and to pay the fines. Okay, so we also have the Paris Agreement. So the 21st Conference of the Parties in Paris in 2015, parties to the UNFCCC reached a landmark agreement to combat climate change and to accelerate and intensify the actions and investment needed for sustainable low-carbon future. So the Paris Agreement builds upon the convention and for the first time brings all nations into a common cause to undertake ambitious efforts to combat climate change and adapt to its effect. So, with enhanced support to assist developing countries to do so. As such, it charts a new course in the global climate efforts. So, the Paris Agreement's central aim is to strengthen the global response to the threat of climate change by keeping the global temperature rise this century well below 2 degrees Celsius above pre-industrial levels and to pursue efforts to limit the temperature increase even further to 1.5 degrees Celsius. Okay, so here I'll be showing to you Secretary General Antonio Guterres calls for global action on climate change. So please listen.
Today I'm appealing for leadership from politicians, from business and scientists, and from the public everywhere. We have the tools to make our actions effective. What we still lack, even after the Paris Agreement, is the leadership and the ambition to do what is needed. And what makes all of this even more disturbing is that we were warned. Scientists have been telling us for decades, over and over again. And far too many leaders have refused to listen. And far too few have acted with the vision the science demands. And we see the results. In some situations, they are approaching scientists' worst-case scenarios. The world's richest nations are the most responsible for the climate crisis, yet the effects are being felt first and worst by the poorest nations and the most vulnerable peoples and communities. Existing technologies are waiting to come online: cleaner fuels, alternative building materials, better batteries, and advances in farming and land use. And these and other innovations can have a major role in reducing greenhouse gas emissions so we can hit the Paris targets and inject the great ambition that is so urgently needed. Let us use the next year for transformational decisions in boardrooms, executive suites, and parliaments across the world. Let us raise our sights, build coalitions, and make our leaders listen. There is no more time to waste. As the ferocity of this summer's wildfires and heat waves shows, the world is changing before our eyes. We are careering towards the edge of the abyss. It is not too late to shift course, but every day that passes means the world eats up a little more and the cost of our inaction mounts. Every day we fail to act is a day that we step a little closer towards a fate that none of us want. A fate that will resonate through generations in the damage done to humankind and life on Earth. Our fate is in our hands. The world is counting on all of us to rise to the challenge before it is too late. I count on you all.
So that is Secretary General Antonio Guterres. Basically, what he is trying to say is we lack commitment. So not just commitment in a national within for our national government, but even commitment commitment among ourselves. We need to understand that our practices, our lifestyles, are contributing factors in the development of climate change. If you have a lot of gadgets, be it cell phones, laptops, you're charging these gadgets from time to time, and so you are releasing carbon footprints, or you are part of uh, the release of carbon footprints. And so um, we should be committed to to do sustainable practices, sustainable activities in a way that will no longer be part of the problem. Rather, we shall be part of the solution. Okay, so that ends my presentation. And again, these are the sources of my presentation. And for the images and videos, uh, the links were already provided. So that's all, and thank you.